Ladies and gentlemen, good evening and welcome to another session of the Nambane Academy Grade 10 Physical Sciences 2024. It's always nice to be here. Katleo, how is everything? Have you completed waves? Are you into electromagnetic radiation? Basically, how is everything with you?
Good evening, sir. We everything is well by my side. We started with electromagnetic radiation and the waves, the different types of waves last week.
Okay, no problem at all. Letabo was here. She has just disappeared. Let's just maybe give her 2 minutes to reconnect and then we'll basically start. I believe we will also start electromagnetic radiation tomorrow because this is supposed to be the last session for waves. So we will basically complete everything today and yeah. Uh, Let me try to locate Letabo. Okay, she's trying another device. There we go. Thank you very much. Letavo, you also said you have started with electromagnetic radiation.
Yes, sir.
Thank you very much. Ladies and gentlemen, let me not waste your time. We have exhausted a lot of waves. I just want us to just conclude by answering that question that was given. But before that, let me copy this and clean it off just for the sake of ensuring that we have everything in place. Yes. Ladies and gentlemen, this question was the question given for us to answer, and it was a homework activity. And thank you very much for answering your homework and completing the activity thereof. The diagram below shows a boy in a kayak on the ocean. Describe the motion of the boy in the kayak while he is not rowing. Ladies and gentlemen, it is very easy. This one is very easy. Obviously, if the boy is not rowing, he will be moving up and down because remember it's in an ocean. Now the ocean will give a wave, it will pass and then give us a trough, another wave will come, so obviously will the boy the boy moves up and down. Very easy. 912. If the amplitude of the wave is 1,2, how far does the boy and the kayak drop from the crest of the wave to the trough of the wave? Now, if I were to put a line here to say this is my line of symmetry, my rest position. Let me change its color and make it red, and maybe put something like that. If I am told that this amplitude here, it is 1,2, it means, and this is now from the crest, and this here at the bottom is our trough, then it means to come there it must now be 1,2. So the question is basically asking about what is the total distance that the boy would have covered. So it will be just now that distance, it will be just 1,2 plus 1,2, which will give us now 2,4. Distance one comma 2 plus 1,2 will give us 1,2 plus 1,2 will give us 2,4 meters. 1 mark, 1 mark. 913, define the term frequency. Ladies and gentlemen, it is a definition, non-negotiable. The number of waves completed in one cycle, 2 marks. Non-negotiable. We can't be negotiating with the definitions. Definitions are critical, and all of us must be able to get a maximum of 2 marks. Ladies and gentlemen, calculate the frequency of the C wave. Round off your answer to 3 decimal places. 3 decimal places. What is happening here, ladies and gentlemen? Let's check. We are told that T is 30 seconds. That is now for the entire motion of the waves. So let's try to find how many waves do we have here. I'm going to try and say 1. Let's take blue. 1. Let's take another orange. 1. Let's take another one, something like purple. Put it there. So how many waves do we have here? Katli, how many waves do we have? Number of waves.
So we have 4 waves.
We have 4 waves. And honestly, it's just easy to understand what and how to identify a wave. So this examiner was trying to confuse us by giving us the 30 seconds. But we understand the 30 seconds is basically what? The entire time taken to complete now what? 4 waves. And we know frequency, it is just now the number of waves over time taken, and this becomes easy. We know we have 4 waves over 30 because that is the time that is given, which will give us something like 0,133 hertz. Remember, correct formula, substitution SI unit, hence you get now your nice 3 marks. Though in this one they are giving 2, no problem. There's no mark for the formula. But anyhow, that will be the principle that one must follow. If the wave covers 60 meters in 30 seconds, determine the wavelength and show your calculations. Ladies and gentlemen, if the wave covers 60 meters in 30 seconds, determine the wavelength. Very easy. 915 wavelength should be equals to, it covers 60 meters in 30 seconds. But in 30 seconds, how many waves do we have? We have 4 waves, and this will give you something like 15 meters. Is it 50? I will have to check something like that. I don't have my calculator with me here. Let me quickly open this one and check. The answer should be 60 divided by 4. It's 15. It's 15 meters, 100%. Then you just get 2 marks for dividing and also another mark for 15 meters. Very easy. And then now calculate the speed of the wave. The formula is very easy. 916 V is equals to F lambda. What is F? 0,133 divided or multiplied by 15. This gives us now 2 meters per second. Ladies and gentlemen, the only key critical thing about this question was, let's take a highlighter and highlight as just identifying the number of waves. If you failed to identify the number of waves, ladies and gentlemen, believe you me, everything was going to collapse. Why is it collapsing? Because if you don't understand that 4 of the number of waves, if you don't understand this 4 of the number of waves, it means your calculation now for 916 automatically falls off. Why? Because of incorrect frequency and incorrect lambda. Katli, questions please.
I don't have any questions. I understand where I got some things wrong.
Thank you very much. Letabo, questions please.
No, sir, I don't have any questions.
Thank you very much. Ladies and gentlemen, let's please allow me now to, okay, let's open this one and we can add most a line here. It's not a problem. Now, when we talk sound as a longitudinal wave, what are we exactly referring to? We are referring to, let's write down, sound as a longitudinal fine. Let's duplicate. Thank you. As a longitudinal wave. What do we basically mean with this? Ladies and gentlemen, we treat sound like any other wave. The only problem with sound is it has the following things. A new concept that we call a tone. And a tone is just the quality of sound. It has a new concept that we call the pitch. All other definitions of the wave are still the same. Amplitude, frequency, wavelength still the same. But with sound now, we are introducing these two critical words. The tone is the quality of sound. The pitch is now what? Is the effect perceived. The effect perceived by the ear due to the sound of a particular frequency. Full stop. And now they are complicating it with nice words here. The effect perceived by the ear. Now what does that say? It says there is now a certain frequency that our ears can tolerate, and if the sound passes now that frequency, it means now we are going to have distortion of sound, and your ear will start now complaining about that. Very, very, very important. Now at number C, we have now what we call noise. We usually say people are making noise. Why are they making noise? Because there's now an irregular vibrations of an object. What do we mean by irregular vibrations? Remember, sound is a vibration. So when there's a lot of people in one place and each one is saying everything that they want, that sound becomes irregular. It is not one uniform song that we understand. If you are enjoying a music of the choir and there's a distort from one particular participant in the choir, we are going to hear the noise. However, if the choir agreed to say they are singing in harmony, all the frequencies are the same throughout, it means we are going to hear the nice tone of sound, which is the quality sound. If they start now changing a certain particular frequency, our ears will hear. Hence, when there's a Pavarotti type of a sound that is going up, automatically, ladies and gentlemen, we get excited, we enjoy the music. Why? Because the pitch is the effect perceived by the ear. So that pitch changes the mood because your ear is basically responding to that. But also, the ear responds to the noise. Why? Because the vibrations are irregular. So the vibration that is coming to the ear, it's irregular, which automatically now creates what? Creates a serious disturbance in your ear. And then this number 4, which is now loudness. Loudness is a subjective term. Okay, let's just say loudness is proportional to the amplitude. As the amplitude increases, loudness increases. So when you say this thing is loud, just remember the amplitude is very large. Very, 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 very large. And it's the same thing with the pitch. Pitch is proportional to the frequency. So if the frequency increases, I must maybe write it. Pitch increases with increase in frequency. Very, very, very important, ladies and gentlemen. Very, very, very important. Very, very, very important. Very, very important. We spoke about the pitch. The lower the frequency, the lower the pitch. The higher the pitch, the higher the frequency. It's as simple as that. Loudness, large amplitude, very loud. Small amplitude, very soft. For the quality of the tone, tone changes or more than one frequency together. That is just the issue of quality and noise. So for us to get quality sound, it means we must have one frequency together. Let me write it down. One frequency together. One frequency together. 100%. One frequency together. Noise, obviously, irregular frequencies. Let's just write not the same frequency. Not the same frequency. So it is something like this. Very, very distorted. Something like not the same frequency at all, ladies and gentlemen. Then now there's what we call an ultrasound. It is now an ultrasound. Now with ultrasound, it's sound with frequencies higher than 20,000 hertz. So anything above 20,000 hertz, we call it now an ultrasound. But this ultrasound uses of ultrasound, uses of ultrasound. Ladies and gentlemen, our ears are designed to absorb everything until 20,000 hertz. Anything above 20,000 hertz will now be problematic to our ears. So the human limit of hearing is until 20,000 hertz. Anything above that, it is going to destroy our eardrums. Uses of ultrasound, the most common one that we know, it's now sonar. The sonar that is used to determine the gender of the child and how the baby is doing for the unborn. But there's also another sonar that is used by the submarines. This sonar, ladies and gentlemen, is used by the ships to determine the depth of the ocean. So we are just going to say sonar because it assists us to do that. So there's also issues of medical uses. Maybe I must just write it, medical uses also. To name a few, it is for tumor removal. It is now to see the scan or let's just say reduce swelling and then breaking up of kidney stones. Breaking up of kidney stones. The other one, it's for welding plastic. Cleaning of jewelry. Ladies and gentlemen, I think this is enough. Just know at least a maximum of 2. But they are going to be nice and clever to say what? To say give 2 uses of ultrasound in medical field. Then you must only refer to medical field. So be on the lookout for you to be able to give them that. Ladies and gentlemen, what is now sound pollution? What is now sound pollution? Katli, sound pollution?
So I'm not sure, but I think it's similar to like visual pollution in the sense that it's a lot of noise in one area.
Lot of noise in one area. It is exactly that. To say when we refer to noise pollution, we are basically referring to the sound intensity as well as the volume or the decibels that we actually can withhold as individuals. So noise pollution is just that maximum irregular sound that you basically get over a certain period of time. So you can get that when people are in one place and congested. Why? Let's say everybody is cheering for the Bafana to be winning the 3rd position in the AFCON. It's irregular sound. Everybody is screaming with different frequencies. Ladies and gentlemen, that will create a noise. And that noise will create what we call a sound pollution because the frequencies thereof are not the same. So sound pollution is exactly that irregular sound of more than enough people or more than enough crowd to actually generate an irregular sound. So that is now sound pollution. And this can be caused by unusual sounds, firearms, motorcycles, aircrafts. At that specific moment when the aircraft is now going to take off, believe you me, there's a very high sound pollution. So it depends, ladies and gentlemen, where we are in terms of the decibels thereof. The amount of volume created as the one that will cause the pollution. Ladies and gentlemen, let's now go to what we call an echo. Echo, it is just known as the reflection of a sound wave from a hard surface. Simple as that. It is basically saying, if this is me against the wall, then I start speaking, there's something, the waves will travel in this direction, and then what will it do? It will now reflect back. Very, very, very important. So it is just the reflection of sound from a hard surface. We usually say it creates a vacuum, or it is loud, or even louder when it is in a vacuum. Very, very, very important for us to actually understand. Very, 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 very important. Ladies and gentlemen, I thought and wished that we could do smaller exercises relating to this, but however, there are basic questions on this. There isn't anything that one must worry about, because even if I am given a sound wave, I will still treat it the same way as I was treating a transverse wave, because the calculations are the same. The only thing will be now speed of sound in air, which will be now just to say speed of sound in air is equals to 340 meters per second. And because it is a constant, ladies and gentlemen, that will be now given. Letabo, questions please.
No, sir, I do not have any questions.
Thank you very much. Katli, questions please.
No, sir, I don't have any questions. I think I understand.
Thank you very much. Then, ladies and gentlemen, it brings us to the end of waves. Tomorrow we'll be working now with electromagnetic radiation, and there will be a test on waves, just an informal test. I will share that link to the test when we have agreed with when are we going to write it. It will be very, very important. And then just know at the back of your head somewhere that you are going also to be writing a smaller informal test. I think it will be about 20 marks or so, only based on the waves, such that we can measure and see your progress thereof. Ladies and gentlemen, if there's nothing else for me to you, thank you very much. Let's meet again tomorrow. But now tomorrow there's an adjustment that I am doing. We are going to start at 6 o'clock. I will send the link that says 6 o'clock. 6 o'clock to 7:15, just to increase the time a little bit. 6:15, I believe everybody is at home by then. Katli, 6:15, sorry, 6.
Yes, sir, I'll be home by then, so that's fine.
Letabo?
Yes, sir. That's fine.
Thank you very much, because there's a situation that we are trying to handle with the grade 12s, so they are going to start now later than usual. So we'll start at 6 with you until 7 o'clock or 7:15, and then I will start with them at 7:45. Ladies and gentlemen, with that being said, thank you very much and have a lovely